Let us now apply the Laplace transform to a slightly more complicated initial value problem. First of all, it is a nice example. We go through all the steps. And secondly, this also shows the bottlenecks. What are the easy steps and what are the difficult steps in this procedure? So we have the following problem. Y double minus 6y prime plus 13 times y equals 0, y0 equals 1, and y prime of 0 equals 0. So first step, take Laplace transform left and right. Well, the Laplace transform of 0 is 0, and on the left hand side we get the Laplace transform of y double minus 6 times the Laplace transform of y prime plus 13 times the Laplace transform of y due to the linearity of the Laplace transform. So, what do we get for the Laplace transform of y double? We get s squared times ys minus s times y0 minus y prime of 0. For the Laplace transform of y prime, we get s times y of s minus y of 0. And the Laplace transform of y is just y of s. So there we go. Then we collect everything with y of s. We have an s squared, we have a minus 6s, and we have a plus 13, so that gets here. And then we have y0 equals 1. So the minus s goes, y0 gives us a minus s. And here we have a plus s times y0 gives us a plus 6. And the y prime of 0 equals 0, so cancels out. And then we can solve for y of s. So there we have y of s, the Laplace transform of the solution of our initial value problem. This is the easy part. Now on to the hard part. We want to find y of t. So how are we going to do that? For this we can try to use our table. So for the numbers in the table, I use the numbers we have in our table. Maybe yours are slightly different, but for us the formula number 9 in the table is this one. With this y of s we get this y of t. And formula number 10 for us is this y of s gives us this y of t. And now we try to convert our y of s over here in formulas such that we can apply formulas 9 and 10. So how do we do this? Well, we complete the square. We have s squared minus 6s plus 13 equals s minus 3 squared plus 4. So our y of s equals s minus 3 squared plus 4 in the denominator. And in the numerator we already write s minus 6 as s minus 3 minus 3 in order to get something similar to this formula 10 over here. So then we have our y of s equals s minus 3 divided by s minus 3 squared plus 4. And then we go on a bit. Now this part is already in this form, so this is fine. We can transform it back now using the formula. And we are left with minus 3 times this term over here, which is almost in this form, except for the b. We have a b squared equals 4, so b equals 2. So we want the 2 over there. No problem, just include the 1/2. And now both of these terms are exactly of the forms 9 and 10. And now we can use our table to transform back. So the first term gives us e to the power 3t times cosine 2t. And the second term minus 3 over 2 times e to the power 3t times sine 2t. So there we have transformed our solution back, and there we have our y of t using our table.